thought I will start with this question. However, I think now that it may be good to introduce a little bit myself and tell where I'm coming from. So basically my journey here started with changing my career from business consulting and business management towards AI research. And then I spent a bit of time researching philosophy of AI from the computational angle, which kind of went through the complex adaptive systems and ended up to developing open-ended computing, basically open-ended decentralized computing model, which I want to talk about from the pretty much conceptual perspective. And right now I'm working with a team of tech and business developers for adopting this model in software and finding adoption in the reality or business world. So the question is, what about thinking that the kind of possible problem or challenges with engineering IoT and edge is basically systemic, coming from the fact that we're looking to these systems as closed boundary systems. And edge IoT and generative AI, they are basically open and complex systems, and trying to think about them as closed systems with closed boundaries start to be problematic when engineering them. And these systems, why they are open? Because they interact with the environment, leading to dynamic and unpredictable behavior, which is a keyword, due to the fact, I hope that is kind of the fact that I don't need to prove, is that they have dynamic system boundaries where devices are joining and leaving, and they may have different owners, for example, in smart cities scenarios. They basically do decentralized processing or decentralized computing, where data flows are flowing across distributed nodes, etc., and so forth, with minimal central control, which is something that, well, actually, we often try to do this central control, but the claim here is it is quite often may kind of go against what we want to do with those systems or what those systems are designed for. And interoperability challenges, which means that those systems, as we just heard through a couple of presentations before, they involve many heterogeneous devices and systems, protocols, and as I said, entities could be different entities which own those devices. So, and now the question is, how do we design systems without considering a priori boundaries for those systems, and whether complex adaptive systems or complexity science can help here. So, yeah. The tenets of this open-ended computing model are that we need systems, and the claim here is that IoT and edge computing may benefit from this. We need systems which have adaptive boundaries, which are defined and basically redefined during operation of the system rather than defined a priori when engineering a system. When new devices leave system, go offline, go online, etc., and so forth. The systems themselves, they have to be what is called resilience or anti-fragile. So anti-fragility is this concept where the system becomes stronger during operation and during kind of its own exposure into the environmental perturbations, rather than resilience is designed from the beginning. And that again comes from complex adaptive systems, that you cannot have a complex system without these properties. Interoperability frameworks basically needs interoperation between all those heterogeneous devices which go up and down and are owned by different entities. That's pretty much obvious. Real-time feedback loops where the system learns itself from its own operation and can reconfigure itself in real time without single central entity controlling everything, which basically, if you have central entity, you have to assume boundaries of a system, which goes against the premise. And that should live into evolving architectures where those systems, as let's say hardware, device, networks, should be able to evolve both into configuration as hardware configuration as well as software configuration, or actually connectivity between them. Once again, without central point of control and without knowing, or at least without knowing precisely what is the system boundary before let's say, starting to run them, engineering them. Which means the system has to start understanding its own system boundary when it is operating. So that leads to this statement that they have to be decentralized rather than distributed by design. And well, the simple difference between distributed system and decentralized is that decentralized doesn't have a center, while distributed can have a center with sort of bunch of nodes running around, controlled by a single controlling entity. So that means that we basically need, for that purpose, in order to build an open-ended computational engine, or substrate, we basically need a computational expression of a complex adaptive system, which is used to be a topic of my research before I went into the implementation phase. And the internet actually was designed as such an open-ended system, which generally follows pretty much all those principles. However, at that time, most probably it would be fair to say that we didn't have technology good enough in order to implement most of those principles. While now, I believe we do. And actually, it's not let's say, that new. So the components that we use in our framework are Actor Model, which is a mathematical framework for the concurrent computation, which is pretty well established and was proposed in '73. Then Object Capability Model, which is probably a little bit, it's secure decentralized computation model, which was proposed also pretty long time ago, however, developed into something that is now started to be useful or usable in 2006 and later with projects within the Web3 ecosystem into the standards. Of course, exponential advances in communication technology, which were not back then, were not available. And now we can see the whole network as actually a computer, which sort of trades off time and space in the network itself rather than single pieces which are doing computational, just exchanging data. Something that is a little bit more new is graph computing concepts, which basically allows us to expose ability for each node in the network, whether it's software or hardware node, to access topology or to learn the topology of the network in the real time. And in a decentralized way, without any central, let's say, node. So, of course, a large body of this so-called Web2 and Web3 technologies related to cryptography, sovereign identity, that's related to security, decentralized identifiers, etc., and so forth, as well as this object capability model, which very nicely started to gain shape with those technologies. So, our claim is that we now have the technological foundation to move beyond this sort of need to have closed boundaries of systems in order to engineer them securely and in a resilient manner. So a little bit about us. Nunet. So we founded in 2019, which is 5 years ago, within the mother company SingularityNet, and then became independent 3 years ago in 2021, successfully crowdfunded through the DeFi space, and now we are a team of 36 people. As I said, working towards implementing the open-ended computing, decentralized computing model into the software and adoption. So what it is? Basically, so I use edge/IoT/decentralized physical infrastructure as basically very similar kind of systems which can be approached with this model. So for those who do not know, DeepIn is decentralized physical infrastructure networks, which started to emerge from the Web3 space, but it seems that it's gaining traction in also traditional computing space. So Nunet developed a model of open-ended decentralized computing. Actually, it started from that model, from the research, and that involves Actor model for concurrent computing on decentralized hardware, meaning decentralized hardware, which is pretty much scattered across the world, connected to the internet, and owned or not owned by different people or entities. So we don't kind of consider boundaries in this sense. At least technology doesn't consider, but it allows to build boundaries after. Object capability model is basically a key part of this implementation of our Actor model because it brings the security or zero trust security into the system via implementing what's called user control authorization network, so UCANs. And graph computing network for, as I said, for the network topology awareness of each device. And eventually, actually, each process which is connected to the network works on the network. And right now, the way we are doing it, we are implementing it via 2 layers. One layer is compute workflow deployment and orchestration layer, which we are rolling out this year, and the blockchain agnostic micropayments layer. So that's another part which we consider important for the basically all those ecosystems, is that we need to build value exchange mechanisms for the devices to exchange value between each other. So, and usually it boils down into micropayment systems where each, let's say, data transfer or compute can be, let's say, remunerated by devices in peer-to-peer manner. And of course, we are running peer-to-peer networks, so I think that goes before, without saying, on peer-to-peer network from the basically open source ecosystem, software ecosystem. So the state where we are now, we are just launched the bootstrap release of this layer of decentralized orchestration, I guess 2 days ago. And that features what we called new Actor model. Basically, Actor model for concurrent computations where each device and each process in that device is exposed to the network as an actor, having its own address and addressable and its own basically capability model. And every actor is communicating to each other via messages and cannot access its own private state. And that's basically premises that come from the Actor model of concurrent computation. And also, it implements the primitives of object capability model for zero trust layer, where each message in that network is signed by the decentralized identifier of the machines that are running. So each machine has a decentralized identifier, which comes with PKA through PKA, I mean signatures. And they can delegate capabilities to each other. And that's basically to my knowledge, the best or the only way to deal with these decentralized systems in a secure manner, theoretically. So now we are initiating community testing on this bootstrap release, aiming for a stable release at the end of this year, and we're onboarding community testers. So in terms of our participation in basically large ecosystem, including now LF, is that we, of course, members of decentralized AI ecosystem, which is SingularityNet since the beginning, 2021, then Cardano ecosystem, blockchain ecosystem from 22, and members of Intersect, which is Cardano members organization from 23, Compute over Data working group, which is basically addressing the question, how can we move computing to data rather than the other way around, so that actually, I mean, sometimes it happens that the algorithm that, for example, has to process, I don't know, database is much smaller than the database itself, and therefore, the substrates that we're building should enable us to figure out in real time what is more costly, whether to move data or whether to move computing towards data. So that is Compute over Data working group, where a bunch of projects are working on that specific question. Then we are members of Linux Foundation, US, Europe, and CNCF and Edge since this year. And also, as probably obvious, we are participants of Web3 ecosystem. So our goals are basically contributing those open components of open-ended decentralized computing model, what we call decentralized compute stack, which I think something is emerging in the, well, at least deep infrastructure, but I think it's very much related to the edge and IoT. As an open source sort of layer or packages that can be reused by the community. And that is it. Thank you for the attention. So I guess I saved some time for questions if there are any.